For packet 4, its standards A2A, A2B, A2C, and A2D. And we're going to be identifying parent functions, we're going to be doing domain and range for both continuous and discrete, and we're collecting and organizing data and interpreting scatter plots. So this one's got a lot in there. What you will be watching on the other videos that you're going to be watching are domain and range from discrete data, which is where you make your list, and that's A102, and then A135 is linear correlation, where you're going to learn about your correlations, whether it has a positive, negative, or no correlation, and just kind of interpreting scatter plots. So what I'm going to do right now is I'm going to do a video over domain and range and parent functions, and just domain and range from a graph. Like I said, for discrete information, you can go get that from the A102. All right, so questions from last year's EOC, 36, 13, 48, and 1. There were 4 questions from this category. 36 is a parent function question, which I'm going to explain in just a second. 13 is a domain and range. 48 is a domain and range. And number 1 is it a positive, negative, or no correlation? Like I said, you got a video on number 1 and, really number 1 on the videos to follow. 48 is also kind of included on there. 48, we're looking for range. We got to remember that domain is your X, range is your Y. Dr. X, Y. And so I always like to write it out, Dr. X, Y. And so when it says range, I always go above that word and I write whether it's the X or Y, which range is Y. F of X is the same thing as Y, so I can mark that out and write a Y. And so all I'm looking for is my Y values. The ones that are in the function are my Y values. And so I go down to my answer choices, and I see which ones have -9, -4, and -1 in my answer choices, and that's G. Okay, a lot of people make the mistake of picking your X values. That's your domain, so you just have it opposite. And then some people try and pick what they are connected to as well, like on H. So G is the answer there. And now, domain and range from a graph, like question number 13. That's what I'm going to go over next. If you take domain and range from a graph, this is a linear function, and there are no arrows. So I always got to make sure that since I know it's a graph, it's continuous, I need to set up my template. I start with domain, range, Dr. X, Y, and I always add my alligators with that corresponding letter on the inside first. And now I can just figure out what is the lowest value, and I put it here. What is the highest value, and I put it here. Lowest value, highest value. So always least to greatest inside of here to ensure that my arrows are pointing the right way. All right, so domain. I'm initially now going to look at my x-axis because that is domain. That tells me how far left and how far right this graph goes. So when I look at the farthest left value, because I'm looking at the x values that this graph contains, it's right here. I draw it up to my x-axis. This is my furthest right. I draw it down to my x-axis. Your values come from the axis. So on the x-axis, this value is -1, and I always do my least value first. And since it's a filled-in circle, I have to add a line underneath my alligator, because it includes that -1. Now I look over here, and this is a value of 1, 2, 3, 4, 5, and so I put that as my greatest value. And again, it's a filled-in circle, so I got to add my line, close it up. I think if it's a closed circle, I got to close up my alligator. Okay, now I got to find my range, which is going to be on my y-axis. That is where the answer comes from that axis. So I look for the lowest point and the highest point that this graph goes from my y-axis. The lowest point is also -1, and I add a line underneath my alligator. And the highest point is a value of 2. And again, I add a line underneath my alligator. So very, very important that we are adding lines if it's a closed circle and leaving it open if it's an open circle. All right, let's look at another problem. This one has an open circle, and so if it has an open circle, you've got to make sure you leave your alligator open. That's what it would look like. Let's see, let me do another problem. We're going to do this one. So again, domain and range. First thing, Dr. X, Y. Let's set up my template. I'm going to go ahead and write my alligators with X in the middle, alligators with Y in the middle. So for domain, I'm looking for my X-axis. That's where my answer is going to come from. I'm looking for as far left and far right as this graph goes. The furthest point left is going to be at a -4, so I fill that in. It's right here. And then my furthest point right is a positive 3. Do I add lines underneath my alligator? The answer is yes, because those are closed circles. That does include -4 and 3, and everything in between. That means all real numbers in between these two values on my x-axis, all real numbers in between -4 and 3, including -4 and 3. We got to make sure we know how to say it in words as well. So my range is going to be all my y values. So on my y-axis, the lowest point and the highest point. And that's going to be a value of -1, and that's going to be a value of 1, 2, 3, 4, 5, 6. And I add lines underneath because they're filled in circles. Again, all real numbers between -1 and 6 on my y-axis, including -1 and 6. So again, make sure you know how to say it in words. This next one that we're going to take the domain and range of is a parabola. Normally we take it with a parabola that has arrows. In this case, I wanted to do an example where we did not have arrows. So domain and range, Dr. XY, we're going to look at my x-axis. Now if it had arrows, this would be all real for my domain because it would keep going left and keep going right. But in this case, it doesn't have arrows. So that means this is as far left as it goes, right here. As far left as it goes. This is as far right as it goes. And so those are going to be the values that I draw up to my x-axis. So this is a value of -1, 2, 3, 4, 5. And so again, I forgot to draw my template. So I'm going to go ahead and do that for my domain. So it goes -5, and again I include it because it's a closed circle. It goes to +5, and I include it because it was a closed circle. Again, if it was arrows, it would be all real, but this didn't have arrows, so it does not keep going and going and going. Now for range, we talked about an easy way to do this for parabolas. Instead of drawing my template for this, now that we know what a vertex is, since we know our vertex is our highest or lowest points, that's what I'm going to find. So find your vertex. My vertex is going to be right there. That is my highest point. Always for domain and range from a graph, we have to have either x or y, and we have to have our alligators in there. But for a parabola, instead of drawing my template, I'm going to just find my vertex and say, okay, that is a value of 1, 2, 3, 4, 5, 6, 7, 8. So is y greater than that 8, or is it less than? It's less than. It goes down. So y is less than or equal to 8. And so that's what I always do. If it's a max point, your vertex is a max, then that means y is going to be less than. If it's a min, or if, let's say your graph was going the other direction and your vertex was a minimum point, then y is always going to be greater than. And so that's just an easier way to find range from a parabola instead of setting up your template. The last type of domain and range I want to do is from a linear function that has arrows. Again, Dr. XY. For my domain, I'm looking for, again, how far left and how far right from my x-axis. But because of these arrows, it keeps going left and it keeps going right, so that would be all real. And for my range, again, I'm looking for my y-axis, how low and how high that graph goes, but it keeps going low and it keeps getting higher, and so this one is also all real. So I just wanted to explain that one as well. The last thing I wanted to explain on this video is parent functions. A parent function is the simplest form of a function. The family of functions will keep the definition or shape of the parent. And so that's how you know what family it belongs to. There's nothing being multiplied, divided, added, or subtracted to the equation, and there are no negatives at all. So it's the absolute simplest form. On this example down here, I've got both parent functions of linear and quadratic. Those are the only two possibilities that we will have, period, on this EOC. And so this one has f of x equals x, but really it's the same thing as y equals x. And for the quadratic, it's y equals x squared. We know that for linear, it's a straight line. It goes through the origin, and it goes up from left to right. And the only option for linear parent function is y equals x. It's the simplest form. We know that quadratic has a square term. It's a parabola. It's a U-shaped figure. It's going through the origin, and it's opening up. And again, the parent function is y equals x squared. We can also tell from equations what is the parent and what is not the parent. So from an equation, I'd like to see, does it have an exponent or not? This first example does not have an exponent, so the parent function is y equals x. This next example has a squared term, so what family does it belong to? The quadratic family. And what is the parent of the quadratic? Y equals x squared. This next equation does not have an exponent, so it's part of the linear family, and that parent is y equals x. And this last one does have an exponent. It's a squared term, which puts it in the quadratic family, so the parent is y equals x squared. So I always ask myself, what family does this belong to? And then you can figure out which is the parent. The parent for linear has no exponent. The parent for quadratic has a squared term. You can also tell from a graph. If I look at a graph, I look at the shape. This shape belongs to the quadratic family because it's a parabola. So this parent function is y equals x squared. I did not just give you the equation of this parabola, I gave you the parent function. When it asks for parent, it's not asking for the equation of that parabola. It's asking for what is the parent, what family does it belong to. So just look at its shape. So this next one is linear. It's a straight line. It's part of the linear family. So what is the equation of the parent function? Y equals x. Again, not what is the equation of this line. What is the equation of the parent? Y equals x. Last example is another parabola. This one's facing up. It's skinny. I know that this is not the equation for this parabola, but the parent function is y equals x squared. Okay, so again, I've now covered the domain and range from a graph. I've covered parent functions, and if you need domain and range from a list, go watch A102, and linear correlation is A135.